This here is 129S, securing web applications, going through the Web Application Hacker's Handbook. And I've got a handout for the class. And I'm not really sure I need an attendance sheet. The only reason I need anyone to record their attendance is if they're planning on never turning in any homework or taking any quizzes. If you do any of that, I'll know you're here. Yeah?
Will you be live streaming these classes?
What's that?
Will you be live streaming these classes?
Yes, yeah, everything here is live streamed.
Okay.
It's being live streamed right now.
Okay.
So let me point that out. So if you go to samsclass.info, that's the website for the class, in case anybody doesn't know. That's like super important information. Because this is where you go to get all your homework and everything you need. So everything I hand out in class goes here also. So I started teaching this class because industry advisors told us we needed this class, and people from Bug Crowd and other companies said that people who earn money on bug bounties all do it using techniques in that book. I must say I haven't earned a lot of money. I've earned several $100 on bug bounties so far, but I haven't. By the way, bug bounties are pretty famous, sort of like cryptocurrency, as in fact being kind of a pig in a poke. If you actually do it, you find out that you're not getting that much money usually. But anyway, you certainly can earn some money that way. Anyway, but these techniques are important to really secure websites, whether you can actually get money. See, like most companies are either smart enough to actually hire security people, or they're stupid enough to not care. And to get a bug bounty, you have to find someone in the middle. And there aren't that many in the middle. Anyway, this is going to talk about how you attack web applications. Things like online shopping sites and email sites and all that stuff. So it's very important to know how those are attacked and therefore how to defend them, because they're everywhere. Every company has a web portal now, and an enormous number of them are unsafe. Because the people, I've certainly seen this in going through Android apps and other things, developers typically have no consciousness of security at all. And they just think it's perfectly fine to do appallingly dangerous things because they don't understand how attacks work. Because it's a whole different group of people that know security, and so we're those people. So typically the role you'll end up being hired for is to be the security officer or the security consultant at a company with a bunch of developers writing horrible stuff, and you'll be trying to patch it up. That's typically what the job is. Anyway, so you need to know the techniques and therefore how to patch them. So we'll go through the essence of how modern websites work, although not in great detail, and then talk about the type of attacks and defenses that are appropriate for them. There's the textbook. You can buy it, and if you are the sort of immoral person who would engage in copyright violation, there's an unbelievable number of PDFs all over the web of this thing, in case any of you have no scruples about these things. I, of course, could never officially condone any such evil activity. So anyway, the quizzes are in Canvas online, multiple choice, open book, so will the final be. I used to do it another way, but I got fed up with it and switched to this. Seems to be all right. And you take the quiz on the chapter before the lecture on the chapter, with the exception of this week when I really didn't think I could assign homework before the first day of class. I would if I could. Anyway, the classes are live streamed through the City College website at that URL. And when we do Kahoots, which there will be some coming up today, you can use this instead, because the City College webcast is delayed by about a minute, I assume, so they can bleep out swear words. And the result is you'll lose all the quizzes because it's time sensitive. So use Zoom if you actually want to pick up the quizzes. And all right, so nothing's due this week. This quiz, I recommend doing it by next week, but I'm not really going to call it late until after February 7th, so that people that are adding aren't already late. But anyway, you should do those quizzes by those days, so you've done the quiz more or less before the chapter. And there's a lot of projects to do. I had one guy take one of my classes, come to the end and say, gee, why did I get an F? Because he didn't do any of the projects. All he did was quizzes. And I said, well, that isn't going to do it. So be warned. There are also hands-on projects, which are, in my opinion, a lot more fun than the quizzes. And I'll demonstrate a couple of them if we have time tonight. All right. And the grading is down here someplace. There, the grading policy. With not much to it at all, there's your grades. There's a bunch of quizzes and a bunch of projects and a final exam. That's it. Adds up to a pile of points. 90% an A, 80% a B, and so on. I think that's all I got as far as policy, except, of course, the usual statement that if people are copying other people's work, I can punish them ruthlessly. Anybody got any questions about anything? Did anybody need ad codes? A couple? Okay, I'll get you at a break. All right, let's start with the first chapter here, because this is introductory stuff and helps you understand what the course is about. So here's web applications, right? Online banking, e-commerce, and the fundamental problem with these things is users keep typing in data, which is then sent up to the server. And they could put nasty stuff in that data. Old websites just let you see an image or something and that's it, but modern websites all keep taking input from the user. They log in, then they put posts on their Facebook wall, then they put up product ID numbers and credit card numbers, and they could put nasty things in all that data, and that's the fundamental problem. So the old days was a static website where you just view like a resume and you see it, and that didn't have this problem. You never put anything up there except just a request to see the data. It was still possible to exploit the web server and deface the page if there was a defect in the operating system or the web server software itself, but the page you put up there typically didn't contain any active content and didn't really add any additional vulnerability. But now you've got stuff like Wikipedia where people can put up paragraphs of data and log in and put up comments and everything. You're publishing content that came from the viewers, like Facebook, which leads to an endless bunch of problems. What do you do when the visitors put up content that you wish wasn't up there? You either have to have an army of censors reading all the content, which is expensive, or something else. That's why the Digital Millennium and Copyright Act gives a safe harbor law, which is the only reason any of this is really possible, which says if somebody puts up content which they stole, it's not your problem if you take it down when you get a complaint. So Google and Facebook do not need to somehow scan everything that goes up to make sure it isn't copied from someone else. That's not really their problem, as long as they take it down as soon as someone complains. This, by the way, is used by a lot of people, like political fanatics, to take down anything they don't like. You can just accuse anyone of copyright violation, even with no basis at all, and almost everybody will just take it down right away to stay behind the safe harbor. They are not required to investigate and determine if the accusation is true. As long as they just take it down, they've dodged the legal liability. Anyway, so that's the game. A lot of data is going up there. And another thing is now your developers are developing quite a lot of code to process all this information, and those are your random developers that probably don't know anything about security and making a lot of mistakes typically. So you got shopping and social networking, banking, gambling, and not even to mention the fantastic world of cryptocurrency, where even if you don't have any other problems with it, the first thing everybody thinks about cryptocurrency is now people can just totally steal my money off the computer. I don't even get a chance to hide it under the bed. And that is absolutely true, and that happens all the time. There's a lot of attacks that steal your cryptocurrency. So if you do invest in cryptocurrency, for God's sake, keep it offline on a thumb drive under your bed or something. If you leave it on a server on the internet, you're asking for it even more. Anyway. So,
gambling wasn't allowed, right, on the web?
The American laws keep changing, but it certainly goes on. In fact, I think they increasingly have to host it out of the country. But yeah.
What about like TD Ameritrade and...
TD Ameritrade, all the stockbroking, and that's done online, and that's all risky too. I've reported tons of vulnerabilities to those guys, and they don't care. It took, I think it was Schwab, took 2 years to patch it. TD Ameritrade is one of the examples. I'm going to do 129S probably next, or 128 next semester, I think. TD Ameritrade, I reported a vulnerability that their password, no, I showed I could steal the password from their app, and I proved it was vulnerable by putting it in a log. So in the next version of their app, they put the password in the log themselves. So they took it, they misinterpreted my vulnerability report, it added more vulnerabilities to their product, which is better than most of them. Most of them just ignore you completely. Then they eventually took it all out, but it's, Android apps are just appalling, and they've taught me to have much less respect for developers than the zero I started with. I mean, developers, I'm not trying to say that they're evil or anything, but they typically have no idea about security, and they are typically so ignorant they don't even understand it's important. I've given talks about security at developers conference, and they come up to argue with me. Oh, we don't need to hash the password, it'll be fine.
They don't get paid extra, that's why.
Well, they have a big complicated thing to learn, and security is just another whole bunch of junk they have to learn, and they would rather pretend they don't need to learn it. I understand that, but somebody at your company has to do a security audit of the product, or you're going to be sorry. And what most people do is hire two different teams of people, developers and then security people, to fight against the developers, and there's a lot of internal friction at the companies, and that's not great, but at least it's better than doing nothing about it. Anyway,
Have you heard about JP Morgan's standard?
JP Morgan, I think they had a bunch of phones too. They all do. Anyway, if you go to my homepage and click the Android apps, you can see a list of I did all the top 10 banks, stockbrokers, and insurance companies. And like 90% of them had serious vulnerabilities. Anyway, so you got SharePoint. Now there's internal stuff used inside your company. Most everybody uses web apps inside their company too. And until recently, none of that stuff was encrypted. This is something I used to have no luck like everyone else saying, if you have an internal payroll app where your employees log into your own server to like see their paychecks like we have at this college, that should be HTTPS. And everybody said, oh, just shut up, it's on our trusted network, everything will be fine. And the only reason that ever changed was because of Snowden. Snowden published the proof that the NSA had hacked into Yahoo and Microsoft and everybody and put listeners on their LAN to get all that juicy unencrypted data. That's what finally convinced people to encrypt it, which, by the way, there's a lesson here about politics. That's what made the change, and that's what makes no sense at all. If you think you're hiding your data from the NSA, just forget it. You cannot hide your data from the NSA because they have an attack you cannot defend yourself against, which is they can come to you with a court order and say, hand over your data, because you're operating in America. So protecting yourself from the government is the one thing that encryption will never do for you if you do business in America. But protecting yourself from criminals is what it will do. And we held on them for years. They should protect themselves by encrypting from criminals, and that didn't move them, but what moved them was a baseless fear of the NSA. I mean, not that the NSA is not going to do something bad, but there's no possible defense. The NSA and CIA, they can do anything they want. You can't stop them. Anyway, so you've got your interfaces to control your cloud servers, your routers and such. You've got your enterprise resource planning, your Office apps like Office Live and all that jazz. All these things are now sending all this data over the network, and it's all working with web applications that are taking a bunch of input, and all that input might be malicious. So web apps are extremely popular because it's very efficient. HTTP is a very efficient protocol. It is connectionless. You send one request to the server, you get one answer, and the transaction is over. If you come back later, it does not remember who you are. Now that was a problem when you moved from Web 1.0 to Web 2.0 because you wanted to do something like log in and see your email, and you wanted it to remember who you are, so Netscape invented the magic cookie, and that's how you do it. You have a cookie that identifies who you are. So that's the game here. Web browsers are, of course, ubiquitous, and everybody's got one, and so if you make whatever your app is run through the web browser, it immediately reaches all the people, and if you make it where they have to install some special software to get there, then it's a lot more hassle for people to use it. It's a huge pressure to just make everything into a web app you can view in a browser. That is obviously the best way to deploy anything as much as you can. So, of course, as we all know, breaches are common. More and more, everybody gets hacked right and left. The government of Norway just got hacked today, which I thought might interest Trump because he seems to be fond of Norwegians. But anyway, the attackers can steal the data. They can take over the server. One thing attackers often do is take over the server, modify it, and let it serve up malware. That is also what the FBI does. They wanted to get the pedophiles who were using Playpen, which was a hidden service behind Tor. So they did what Anonymous had done a year earlier. They hacked into the server, changed the website so it handed out malware, and let it keep running so the pedophiles would download malware, and then they could find out who they were. So it can easily be done. You can also use denial of service attacks to take down sites and freeze them temporarily. And so an awful lot of people say a site is secure because it has encryption, but that is not the whole story at all. Encryption prevents some attacks. There's a whole lot of attacks it does not stop. Security is complicated. That's why it's appropriate to have some sympathy for the developers that say, look, you know, I've got enough work already. Don't tell me I have to learn all that. There are like 100 ways to attack a website. Encryption will solve a few of them, but not a lot of them. So, all right, here's an example of a typical site. I've been arguing with these people for more than a year now because I made a blockchain voting system. I thought it was interesting. And they have made a blockchain voting system. They're trying to sell it, and they advertise it as 100% secure because it uses blockchains. And so I contacted them. I said, do you have any security staff at all? Because if anybody there has any training at all in security, they will tell you, you never ever say this. There's no such thing as 100% security, no matter what you do, and blockchains certainly don't provide it. Many cryptocurrencies like Lisk were completely destroyed by being hacked. You can hack the Bitcoin blockchain. You can hack all of them. I watched them hack the Bitcoin blockchain on stage at Hope. There's nothing is 100% secure. Nothing cannot be hacked. You have to make a more careful statement. You can say it is more secure than something else. It is secure under certain conditions, but there's nothing 100% secure. But these guys don't care. They're just pushing their product. So your textbook authors went through a lot of websites, and they found, as you can see, most of them have a lot of vulnerabilities. SQL injection on 30% of them, broken authentication on more, and the most popular thing of all is cross-site scripting, which is certainly true. Cross-site scripting is so common you can find it very quickly. There's all kinds of websites that list all the cross-site scripting vulns. Companies will never pay you a bug bounty for telling them, and they'll typically not even patch it. Almost every website has cross-site scripting vulnerabilities. Companies don't take it seriously because by itself, it does not let you hurt the company. It just lets you hurt other users. When combined with another flaw, it can quickly lead to total system compromise. But they don't think of that. And cross-site scripting, they typically ignore. Cross-site request forgery is closely related to cross-site scripting, but it's nastier, where you get to send a request which gets re-executed in a different context. So you can put up a link which doesn't work when you click on it, but when an administrator clicks on it, it works and does something like erase the database or dump out all the data. Because it uses their credentials when they click it. So all you have to do is trick someone into clicking a link and you get in. You can also use a stolen cookie to imitate somebody else, and that's another kind of cross-site request forgery. So this is a hack that came out today, the news article about this. There is some place called SynVR where you can download virtual reality porn movies. And there are people doing this, and they got hacked. And they got hacked through a very entertaining technique, and the guy in fact used Burp, which is what we're mostly going to use in this class. Burp is the main attack tool written by your textbook author. Here's a request to the web, a post request host. He sent this request to the server, and as a reply, he got their whole database, including passwords. And the interesting thing about this is, notice how the authentication works. There is no authentication at all. No cookie, no password, no nothing. This is quite common. This is called insecure direct object access. Quite a few routers work this way. You go to the configuration page of your router, it has a login page, put in administrator name and password, then you move from index.html to admin.html. If you just put that in your bookmarks and go directly to admin.html, you're the administrator. You don't have to pass through the login page. It's like the toll booth in the desert in Blazing Saddles. You can pay the toll, go down the road, you can just ride right around it and get where you're going, because they didn't actually bother to have a folder structure and permissions and user accounts. They have security through obscurity. They think you won't find how to do it unless you go through the approved way. So this has a request to dump all the data, which does not actually check that you're the administrator with a cookie or something. Just if you know the right URL to go to, it accepts the request, lets you do administrative actions. And those are the guys that are distributing their porn products, which, you know, you would think people might realize that that's going to mess with their business, because most people purchasing those products would probably rather not have everybody in their life know that they're doing it. So it would behoove them to actually protect their database. Yeah?
What did you say it's called? Insecure direct access?
Insecure direct object access. Yeah, that's what they used to call it. It's where anybody can actually get to this, can actually get to the object, not just the people that are allowed to get there, because you don't check permission on every request. Yeah. It's also called security through obscurity, like hiding the key under the mat. Anybody can get the key, you just hope they won't realize where to look for it. And here's the OWASP top 10 risk for mobile. There's also one for web apps, which we'll go through more later, but it goes weak server-side controls, insecure data storage, insufficient transport layer protection, like sending unencrypted passwords over the internet, data leakage, where data leaks off where it shouldn't go, and a lot of others like broken cryptography, where you do some encryption, but you do it wrong, which I must say something like 90% of all Android apps I found do that. They use private key encryption to encrypt stuff, and then they just hide the key on the phone, thinking you won't find it, which is a terrible way to do it. And then the last one here, lack of binary protections, is the one that 90% of all Android apps have. They just give you the source code with the app. They don't bother to protect it the way you would with the C app. So you can totally read it and find out what they did and hack in. But the users can't see that, so that there's no security audit process at all, as far as I can tell, on most Android apps. They just go for the cheapest outsourced developer, and if it looks good, they just send it to their customers and call the job done. Nobody ever asks how it works. Anyway, yeah, so I did a bunch of them. Here's Here's the people some of the people I notified. I've got a page full of that on my website up at the top. I went through all the top 10 banks and so on. I also went through a lot of colleges, found 19 colleges that had been hacked and were selling Viagra and tried to get them to care. In general, nobody of these people ever care. You call people and tell them you've been hacked, they just hang up on you or swear at you or blame you for it or something. This is why they call this white hatting, and it is for amateurs. All the professionals, what the professionals told me, and I didn't believe it, is if you are on the web and you see somebody with a security problem, don't say anything, just let them get hacked. That is the professional response. And I said, I can't do that. And they said, well, you'll learn. So I learned. They're right. That if they let themselves do something that stupid, they're also too stupid to understand a vulnerability report. If they cared, they would have a vulnerability reporting process or a bug bounty page. If they don't, all you're going to do is invite a punch in the nose for yourself. By telling them about a security problem, they will just blame you and punch you, generally. Well, mostly they'll just ignore you. Yeah.
Is there any shift since especially Equifax last year got their stuff stolen? Is there any shift whatsoever in the secure community that work for banks or at least big institutions like that? So if you do report something, there's no large shift. I mean, every time the big hacks, you always think they're going to make a difference, and they don't. The only thing that will make a difference is actually government regulation, and that's not coming. The other thing that happens is once people seriously get hacked, 3 or 4 times, then it'll actually improve their security, and that's all that does it. And I think the rate of new businesses coming up exceeds the rate of old businesses that have been hacked, so the number of insecure sites just multiplies. This is like SQL injection. SQL injection, Rainforest Puppy invented it 17 years ago, and at that time 11% of the web was vulnerable. This guy found 30, but a sample may be different. And after years of training everyone about it, now 11% of the web is still vulnerable because every site that gets fixed, somebody else graduates and puts up another copy of the same stupid stuff. That may actually go down because of PHP 7. That may help. But anyway, yeah.
What's the legality of trying to attempt these? Because you said you tried them on some banks.
Well, yeah, I did not hack into the bank servers, although I'm not sure what I did was legal either. I thought it was. I analyzed their Android apps, and what occurred to me is by analyzing the app instead of the server. See, I used to go through servers, like college servers, and then they said, you're violating the CFAA. So I said, fine, I'll analyze the app. Well, now I'm violating the DMCA. I said, well, I'm afraid I've finally discovered something that the Department of Justice official told us at B-Sides 2 years ago. He said, we are aware that everything you do in the world of security research is illegal. But you can trust us to only prosecute the bad guys. We have prosecutorial discretion. So that's the way it is. Now, of course, if you just set up a test system in your own lab and hack that, that's all right for practice. But if you want to do any kind of research of what's out there in the world, it's all technically illegal. And you have to have a lawyer, you have to consult with your lawyer and decide what level of risk you're willing to put up with. I try very hard never not to assign any homework that is illegal. Although I have, in fact, assigned some homework that was illegal in the past without understanding it. So I try not to, that I think the college would have a problem with that. Although, in fact, there is no actual administration that functions here that supervises anything. But if there was, they would care about that. But I personally care. I don't want to get the college indicted for signing illegal homework. So I try not to assign students any illegal projects, but certainly my research has some legal risk involved with it, just like everybody else's. I just try to stay behind the other people doing it, and I have a lawyer, and I talk to my lawyer, and I've needed my lawyer a few times. If you get in trouble and you need a lawyer, I've got a good guy. Because even if you are very well-intentioned, you can end up needing a lawyer in this business. Because the laws are very strange, and a lot of quite good things you might want to do turn out to be illegal. Like somebody put up a fake Hushmail site in Belize. And they started harvesting passwords. And so I said, I can hack into that. I happen to know there are no cybercrime laws in Belize, and there aren't. So I can hack in there and steal the passwords back and notify those people. I talked to my lawyer, and he said, no. If you're in America and you hack into a Belize server, they can prosecute you for breaking American law, even though it's victims in Belize. And I'm like, dude, there's just no fun at all. But anyway, so I didn't do it, but it seemed perfectly fine to me. Seemed like a good thing to do. Anyway, so users can submit arbitrary input. They can put it in parameters, cookies, HTTP headers like the user agent, and so on. A lot of developers put JavaScript in the browser to verify things, like your social security number should only contain a certain number of digits and stuff. And that's fine, but the user can defeat that control because it runs on their computer. And an enormous number of developers do not understand what part of their code runs on the user's browsers, and what part of their code runs on the server. So one of the things that happens over and over and over again, happened to Microsoft about 4 years ago, people have some kind of giveaway program where you can sign up to get a free something, and you can just modify your browser, delete the cookie, get another one, change the number from 1 to 100 and get 100 free things, and people were getting t-shirts and thumb drives in vast profusion. This keeps on happening over and over and over, that the developer wrote something and then had some important part of it, like the price, is sometimes specified in the client, not on the server. So you can just change the price of the item you're buying. These kind of mistakes happen all the time. All right, Burp is a very good tool for this. Even if you don't find it convenient to disable the JavaScript in the browser, which you might not because some of that JavaScript might be necessary as a function, you can let it run and then capture the request on the way out with Burp. Burp is a proxy. Your browser sends a request, Burp grabs it and holds it. You can now change it before it goes up to the server. So the browser does all of its logic, and you then undo it and change the request into something malicious, and off it goes to the server. Another technique, which is really very easy, and we do it in my one advanced hacking class, is you just write your own Python browser. It only takes about 6 lines to make a browser. It's very simple. So you can just write your own code that sends a request of any kind you want to the server, and Burp is just a graphical interface that makes it easy to essentially do that. So you can change the price of an item, you can modify a session token and be somebody else if you're able to find out somebody else's token, either by stealing it or by perhaps predicting it, because somebody might have a token that's not really random. You can change parameters to jump past things. We'll have a lot of those. For example, you can, if you have a website that's many pages, the first page you log in, second page you say what item you want, third page you put in your credit card number, fourth page you buy it, you can sometimes jump the third page. We'll go to the second page, we'll just jump right to the fourth page, so it thinks we put in a credit card number, but we didn't. But just like that thing I was showing you at that porn site, they assume that getting to this page implies that you went through all our steps to get there. They don't think maybe they skipped a step. SQL injection is a big one. You'll be doing that in the second project if you haven't done it before. If you've taken my hacking class, you've already done SQL injection projects, but if you haven't, you absolutely have to. This is the most important vulnerability in the world. If you only know one thing about security, this should be it. More than 95% of all the stolen data in the world was stolen with SQL injection because it is extremely powerful and extremely easy. All you do is put in funny data in a field with apostrophes in it, and it dumps all the data right in your browser. It will make you sick. Directory traversal was like this in the 90s. You could just have a website, and you could go up here like samsclass.info, and you could just type in stuff like this. System 32 Windows, System 32 CMD, and just enter and you get a command prompt right there. As administrator, you could then take over the server. It was that easy. And SQL injection is almost that easy. You just type in some funny looking stuff and blam, you have everything. So it is extremely dangerous and very common on the web. So here's the reason why this all happens. Like I say, a lot of people are putting up websites, paying for them, running CEOs of companies, being developers, and they don't know anything about security, so they don't even understand how dangerous what they're doing is. You have a lot of custom development, so you take people and tell them to modify things. You don't just use a standard framework like WordPress or something that might have a team of people checking it. It's very easy to make a website. It looks good. People are buying stuff. Everything seems fine. It's not immediately obvious that there's a terrible security flaw here. And of course, things keep changing. There keep being new vulnerabilities found every week, like Meltdown and Spectre. That's why a lot of people in companies are just frustrated with security. Look, security just drives you insane. Every time it's okay, next week they tell me it's not okay. I have to do this, I have to do that. I wish you people would all just shut up. Linus Torvalds, the guy in charge of Linux, is the archetype of this. He says that all the people in security are just a bunch of masturbating monkeys. They should just all go home and get a real job and write productive software instead of inventing all these exotic hacks and inventing all these exotic defenses and driving us all insane. Just knock it off. That was Microsoft's position for years, until about 2008 or so. Their official position is everybody should just shut up about security flaws. If you don't tell anybody, no one else will find them and everything will be fine. And that is a very popular position for developers to take. And that's why when you go to a company and report them a security flaw, their usual solution is to just kick you in the face so you shut up, and now everything's fine again. We were fine before you came in the door. After you kick this guy out, we're fine again. we don't have to like spend a bunch of money and hire consultants and change our product. We just need to get rid of this idiot and keep going. All right, and as I say, lots of people are trying to get more and more done with less people, so they're not in a hurry to pay for a bunch of security audits and code improvements when it seems to them like they can just keep going with their current insecure stuff and be fine. And that's why if you do get them to do something like for PCI compliance, then what they would like to do rather than actually improving their code is just buy a magic box to put on the network like a web application firewall, which will improve, and that does improve their security to some extent. And the thing management loves is you don't have to like disrupt the whole company, add another division of security people. You just buy a box. Now I have one price, a monthly annual fee for the box, and now the problem is solved. And that's not a perfect solution, but it certainly is an improvement. That's why if you take credit cards in large numbers, you are required to have a web application firewall because it is pretty good. Global solution, sort of like antivirus. So you can put firewalls and bastion hosts. That was the old solution. You have a special strong device on the edge of your network at the gateway to block the attacks. And that stops old-fashioned attacks, but it doesn't stop web attacks because web attacks are not malware. They are not deformed packets. They are perfectly valid traffic sending perfectly valid data up to the server, which is then misunderstood at the server. So your edge devices can't know that your name shouldn't have an apostrophe in it. It's perfectly valid GET request. It goes through. It says, why should I block it? So you can send transactions up to the server by the web app or by the Android app, your phone app. And so the web app now has to be a security barrier. Another fun thing is errors made by other people can compromise your security. The libraries you're using can have vulnerabilities. The operating systems have vulnerabilities. Your hardware can have vulnerabilities. Like Meltdown and Spectre are hardware flaws in the processor. So it's really kind of ruthless.
Yeah, Intel scandal.
Yeah,
I love the Intel one.
Even when you didn't do anything wrong, other people you're trusting will do something wrong, and then you're still in trouble. So now they can attack users instead of servers with things like Crosssite scripting, where I don't compromise your server, but I use your server to bounce an attack which hurts another user, and that still is something you would like to prevent. If you have password, if I get into your email with something like Crosssite scripting attack, which is easy to do, then I own your whole life because everything else I can reset the password and they'll send an email message to reset your password, unless you're using two-factor authentication, which very few people are. It just came out today from the Enigma conference. Google said only 10% of all Gmail accounts are using two-factor authentication. So the rest of them are easy meat. Anyway, so some vulnerabilities are decreasing. Back in, say, 2000, Windows was completely full of ridiculous holes. Office was all full of ridiculous holes. Internet Explorer was, Word, PowerPoint, all that stuff was just, Outlook Express especially, was just appalling because Microsoft officially ignored security. They had the position, a lot of people still do, which is security is just a waste of time. Just put out more features and smileys and everybody will buy the next version and nobody cares about security. But Microsoft changed their mind about that in 2002. And other companies reach a certain stage of maturity when they finally get tired of everybody being hacked and they realize, you know, we really just have to write better code. We can't just carry on and pretending it's okay that everybody's getting hacked right and left. So certain things go down. Your code execution flaws have gone down. SQL injection has gone down by this test. Anyway, so some vulnerabilities have gone down. For example, buffer overflows were the #1 way you take over things until about 2008. And then Microsoft added address-based layout, randomization, and data execution prevention, and a bunch of other stuff. And now it's only about 5% of attacks run through buffer overflows because they finally fixed that pretty much. But web apps remain outrageously vulnerable. So if you have a phone or a computer, you can do the Kahoot, and I will start a Zoom session so the remote viewers can do it. By the way, a student told me that if you do connect remotely over Zoom, you should disconnect from the City College stream. If you try to run both streams at the same time, apparently it causes trouble, which is not too surprising, in fact. But anyway, all right. 4 questions in this one. Okay. Right, what makes Web 2.0 different than the earlier web? And you got 4 choices there. User submitted content. Good, most people got that right. All right, what attack does SSL stop?
Oh.
All right, you can, if you do a man-in-the-middle attack and try to change the data, you won't be able to do it because you won't have the encryption key. These other things, it does not stop. All right, what's the most common website vulnerability? There might be some argument over this one. Okay, cross-site scripting is by far the most common. If you wanted to be super pedantic, you might say meltdown because it affects all the processors, but it's actually not a real vulnerability being exploited very much yet. And it's supposedly been patched in software, so anyway, cross-site scripting is what really remains a vulnerability on almost every website. What's the most important defense method? Good, thank you.
Air gap. Application that accepts touching. You sure it's not air gap?
That would be nice.
What?
But he says air gap. Of this choice, updates is the most important thing. Amateurs mostly think antivirus will save them. I'm glad none of you think so. Updates is what professionals think will save them. Okay, finally, there's the winners. I don't think I'm going to try to do the next chapter tonight. What I want you to get started on is doing the homework. So let me just demonstrate the first couple projects.
Yeah, the fun part.
Yeah, that's probably the fun part. We'll pick up next time here. So, all right, so here you are. Come on, it's not moving. Okay. So, we're here at 129S, and you got projects to do, and these start out very easy. You don't even need any software at all, other than a web browser. A lot of hacking, you don't need anything but a web browser. And it just depends on how big the vulnerabilities are. And the first couple of vulnerabilities here are the big ones you can drive a truck through. You don't even need anything. You can do these projects on a cell phone. And sometimes people do at my conferences and stuff. So this one is command injection. This is one of the simplest vulnerabilities. It is an easy mistake to make, and it is very easy to exploit. So here's, so first you have to learn a little bit of Bash. These are running on Linux servers, so you have to know a little bit of Linux. So in case you don't, let me just give you maybe 10 minutes about Linux, and you'll probably rehearse it in this project. So a Mac runs Unix, which is close enough to Linux. So if you have a command line, you type date, and you see the date. If ls is the most common command of all, it lists all the files in the current directory. And you can put switches on it, like ls-l will show you the long form of the list, which has the date the file was last changed and the permissions and how big it is and stuff like that. All right, you can print your working directory. This is where a lot of people get confused in the command line. There was a game long, long ago called Zork. And my whole generation played this game called Zork, and we learned something that modern people have forgotten, which is you have to remember where you are. In command line, you always have a working directory, and PWD will show it to you. So my working directory is my home directory, users sambound. And I can make a directory with mkdir. I can make a directory called dfoo, and I can change directory into dfoo. And now, if I print my working directory, I'm now in users sambound dfoo. And now if I do an ls, there's nothing in there because I haven't put anything there yet. So you have to know where you are, and you can refer to things by a relative path. So if I wanted to access this file here called temp, I could do ls temp. It's not there because it's above me. It's // temp. And this is an important thing to understand, indirect addressing, relative addressing, where I take where I am, go up one, and find it up there. And that will find it. .. takes you up. If I do ls-a, every directory has these two files, dot and dot. Dot is the current directory, and dot is the one above it. And those files are what creates the tree-structured directory system. Anyway, so now you can echo things. If I echo, hi, it just prints hi, and I can now put something in a file. I can echo hi into a file called foo. And now if I do ls minus l, there's a file called foo that is 3 bytes long because it put in hi and it added a carriage return at the end. If you want to see what's in a file, you can cat it. Or, as we're going to do a lot more later, you can nano it. Nano is there are many kinds of text editors. There are the real professional ones like VI, where you actually have to practice it all the time, and it's fast if you're an expert, and everybody else is always lost. There are the really gentle ones like Notepad. It lets you use the mouse and everything. And in the middle is Nano. That doesn't let you use the mouse, but it's less baffling than VI. Anyway, so there's, that just opens the buffer. If I nano foo, it will open my file, and I could now edit a file here. More stuff. Save it with Control. At the bottom, it has information to show you how to use it, like Control X will exit. This is a very, very old notation. The reason all the letters are capital is this dates from like the 70s when computer keyboards only had capital letters. So Control X, now save modified buffer, Y will save changes, and Enter will save it on the expected name, which is foo. I could rename it by typing in a different name. And anyway, so now I can put things in that file with output redirection. If I print date, it'll print the date. I could take what was going to go to the screen and put it in foo with 2 greater than signs. And that will add it to the end of the file called foo. So now if I nano foo, it's got hi, more stuff, and the date. So that is probably enough. Shows you how to send some literal text into a file. And that's really all you have to do what we're doing here. And there's even an online place you can practice if you have a Windows machine and no Linux virtual machine or Microsoft PowerShell Linux simulation or whatever that nonsense is. Linux subsystem on Windows.
Sigwin, maybe?
No, there is a thing built into Windows now. You can go into PowerShell and install some kind of Linux on top of your Windows. And I play with it a little bit. It's a little screwy, but you can do some Linux right in your Windows. Anyway, so you can go to this thing and practice a bit. But once you know a little bit of Linux, just a few commands, you can now start exploiting this here ping form. This is a vulnerability that many home routers have. So if you go to your router typically has a test your network connection page where you can ping something and it'll tell you if the ping's made it to the internet or not. All right, and so that's what this does. You can put in an IP address there or a name like google.com. So I put in google.com and send pings. It will send 2 pings to Google, tell me I got 2 replies, and then it's done. Okay, that is what you're supposed to do to test your internet connection. Now, the issue is, how did the programmer write this page? And if you are a really sleazy programmer, you're writing your language, your web page in something like PHP. But you can't figure out how to send a ping from PHP. So what you do is you just create an operating system command where you execute it in the bash command line. You say ping, and then you put in whatever the user put in and call that a command line and execute it at the operating system. This is very, very common. And command injection flaws are typically caused by doing this. You have something in one language, and you use it to create a statement which you then send to something in another language. Now this is like you have something in English, you try to construct German and send it to somebody who's going to understand it in German. You have a translator in the middle who might foul it up. You might not have a good translation, so it's misunderstood at the other end, and that's what happens here. So this thing was only supposed to let me ping Google, but if I take google.com and put semicolon ls, if you can put more than one command on a line, if I send this, I now get the pings, and then I get a list of files, and that's because that is perfectly valid Linux command line. If I go here and type ping minus count to google.com, it will ping twice and come back. But if I put semicolon ls, it'll do the same thing. Ping twice and then do an ls. You can put as many commands as you want on a line in Linux. You just separate them by semicolons. So here it is. Put one command, semicolon, next command, semicolon, next command. And so since the developer didn't think of that, and they let me put in as long a thing as I want, and they didn't remove special characters like semicolons, I can abuse their ping form to do other things. So you can do anything you like. You can deface my server, add extra files to it. This is not the same server that serves up your homework and stuff, or the quizzes. It's a server used only for these hacking projects, so as people destroy it, they aren't destroying anything too crucial. So if you put your name in that file, which you should be able to do by injecting appropriate commands, you will get on the winners page. And let's see if I can somehow defeat this irritating feature of my operating system there. All right, so here's various people testing it. All right, I tested it before class. You can get yourself on that page. If you add yourself to a certain file, I'm running a script in the background that will put you on this page. So that's what you have to do here. Figure that out. It shouldn't be too hard. And there's, after you do that, I would go do extra credit. Here's the main projects that I recommend, and there's a bunch of extra credit projects you can do down here, which are well worth doing too. And if you do enough extra credit, you don't need to take the final, and it makes up for anything you did wrong on the quizzes and all that jazz. So it's usually quite popular. So the first one, 1X here, is more command injection challenges. So let me show you those. If these things are good, clean fun. So here's more command injections. This one is a buffer overflow. So let me go here. This goes to one of my servers. Okay, this is a simple kind of buffer overflow. Now this program is in C. You don't really need to know any C for this class. We're not going to do any binary command line exploits like that. That's the exploit development class 127, which comes on Saturday. But here is the C code that is being exploited here. This is an interesting kind of vulnerability because although it is not the most common type of buffer overflow, it is very hard to fix. So here I have the main program. The main program prints out what's your name, it reads a variable name, then it has a second, then it calls a function called BO with the name and this thing, uname -a. Now uname -a is just a harmless Unix command that tells you what version of Unix you're running. But down here it has two variables. This is the buffer in which the name will go, and this is the command. Then it copies them in with string copy. Copies the thing that came from here. Now up here, these things could be up to 200 letters long. In the subroutine, they can only be 40 letters long. This is quite common that a developer makes a mistake. Something that's big gets put in a box that's too small. That's what makes the buffer overflow. So you might have a name that's 200 letters long, and here it's going to copy that long name into the buffer, which will run past the buffer and hit the command. So you have an overflow from one variable into another variable. It does not go all the way to the end of the stack frame and correct the instruction pointer, so defenses like stack canaries and such, which are the defenses against these things, do not take effect because it doesn't destroy the integrity of the subroutine process. It just corrupts one variable, and that is very hard to spot. So now it prints out something and tries to execute this command with system C, and notice again, this is what I said before. Instead of doing whatever I wanted to do in C, I take a command and then send it out to the system to execute it at the bash command shell. So this is just what is typically the kiss of death. You use your code to create something, you then execute it in another environment. That's dangerous. And if you don't, it means you have to thoroughly understand both environments to know what you need to filter out, and typically people don't. So what it means is, here's a form. So if I put in a name like Sam and say execute, it will just say your name is Sam, I'm executing the command uname -a, and then it tells me what version of Linux I have. So that's not exciting, but that's what the developer intended. But if I want to abuse it, I put in this string, which is 40 characters, and then ls. And now, when it executes, it prints out the name, which is 42 characters long, because the print command is unaware that we're supposed to stop at 40. It just goes right to the end of the second one. But the ls leaks into the command, so now it executes the command ls. It has erased the uname -a and put ls on top of it, and now executed in ls. So now I can do commands here by injecting them at the end of that. So I can have ls, semicolon date, semicolon who am I, and do a variety of Unix commands. So now it does an ls. Here's the date. And there's who I am. I'm www.data because it's exploiting my Apache process on the server, and Apache runs as www.data. So again, you can execute commands. So now your first challenge is to do the long list. And if you try to do it the simplest way, it won't work. It's a little bit harder. If you do ls space -l, what you get is ls, not ls -l. And it tells you that right here, executing command ls. The space was interpreted as the end of the word, and the -l was not used. So you have to somehow trick it into not regarding the space as a terminator. And there are a few tricks. The simplest one is just put the whole thing in quotes. But you get a long list, and then again, put your name in this file, and you will end up on the Hall of Fame. Here's the winners page for this one. All right, so that'll put you on here when you win. And the next one is probably even more fun. It's been quite popular at conferences and such, which is this one here, ImageMagick. This is a real vulnerability that affected almost all Linux servers about 2 or 3 years ago. If you have, so let's go to this web page. So here's a web page, and I actually just copied this code from like a code repository on the web. Here's a code to make like a image hosting service in PHP or something like that. I just copied standard code, made a couple modifications. There's a whole bunch of people that have like a profile page where you can put up a picture of you or something. And so you have to have some way to send up an image, and then they have rules on the server. It can only be this big and all that, so they want to modify images on the server. And the standard Unix library to do that is ImageMagick. So let's do it here. I have some harmless image on my desktop to use. I have a picture of Tux, I think. Yeah, there's Tux. Okay, let's send Tux up to the server. If I send up Tux, and then upload the image, my website prints out all the commands it's executing just so you can see what happens. So it sends it up there, it removes any old file with the same name, it then uploads the file, removes the thumbnail, it now creates a thumbnail. This is what I use ImageMagick for. Convert to a 300 by 300 thumbnail, this file. And that result is, whatever you send up there, no matter how big it is, will be here in a thumbnail, and if you click that, you'll see the full-size version, which is a lot bigger. So that's what I use ImageMagick for, to shrink things. So that's used as intended. Now, ImageMagick made the same coding mistake. So let's try another image. And this, by the way, is why I have to do this over secure connection, because this got me on a lot of blacklists, including Cisco blacklists. I was doing a conference at Cisco, and my website is now blocked for hosting malware because of this project. Because just viewing the instructions is interpreted by stupid IDSs as an attack. And that's because of this text right here. This is how you exploit the ImageMagick flaw. You take that plain text and you put it in a text editor and save it as if it was an image. So here's a text editor, which for some reason is not popping up. What's going on? Oh, it's down here in the corner. Okay. So here's my text editor. I put in that junk. And I save it as an image. We'll come back to talk about why. Let me just start by saving it. I'm going to put it on my desktop and call it attack1.jpg. Okay. So there's the file, att1.jpg, which has a JPG extension, but it's not an image. It's just 4 lines of text. If I upload that file, then what happens is it prints hello and it prints the date. Now, let's take a look at what was in that file, and you will see why it happened. What's in this file is, you can put some text around an image which is used by ImageMagick to alter the image. And in particular, you can put a background color behind the picture in ImageMagick, and you do it with the fill command. And for some ungodly reason, you can load the color with a web request. So to fill it, I'm going to harvest the web request from the URL command here. And the way they implemented the URL was to just go to the command prompt and execute a get or curl. So they took the text I put in between these quotes and just put it in a bash command line, like that google.com in the ping form, which is the same stupid mistake. So if I put in a URL and then the right combination of punctuation marks, and then put echo hello semicolon date, these things are executed at the Unix command shell line. It has a command injection vulnerability. You can just put in a couple of fancy punctuation marks, and then you can put bash commands in there, which will just be executed on the server. So, and this was a real vulnerability. It affected almost every Linux server for a while. They've, of course, been patched a couple of years ago, so people that have put on their updates are okay. But I had an old server here. So you can add extra commands there, and again, your challenge is so if you manage to put your name in that file, it will put you on a winners page again. And so these are good things to do, and you'll see the evils of command injection, which is one of the most common vulnerabilities. It is one of the most commonly exploited vulnerabilities. Cross-site scripting is much more common, but this vulnerability is quite common and very easy to exploit. So, any questions about anything? Well, I think that's enough for tonight. I'm going to just clean up, and I'll go up to the hacking lab, which is Science 214. If anybody wants to work on campus, you can work in there for a while. If you want to work from home, that's fine too. All your homework comes in by email, and all the quizzes are online in Canvas. So I'll see you next week, or if you prefer, you can connect remotely through the streaming service next week and do it from home.